Everyone, welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 26 is on the screen. Let's get started, please. By now, we should be experts at all these three, yes? Yes, Mr. Q. All right, good. Give you guys about 5 minutes. You should be all ready to go. Copy and go. All right. We should be done by now. All right. Start with 1A. So, check with the neighbor, see what they got for 1A, and then I'm going to have someone get us started with the process for that one, just to make sure we got it complete. All right, let's see. The conversations. Who haven't we called on in a while? Who haven't we called on? What do you guys think? Who? How about Eileen? What? All right, Eileen. What did we do first? All right, phone a friend. She said Autumn. What do we do first, Autumn? So 8 with 1/3 times 4. And if you got that so far, that is correct. The 4 that's here in the numerator needs to go away to the side and replace that with a 1. So there it is. Next, what does this become? What does that become, Carlos? No. What does this 8 to the 1/3 become? So cube root of 8. Not square root, it's cube root of 8. Okay. Then we get a parenthesis. Bring down the exponent of 4. All right. Next, continue. Tell your neighbor what cube root of 8 means. It means what? This 3 indicates what number times itself 3 times give us 8. Tell your neighbor what number times itself 3 times give us 8. Then Dayami is going to enlighten us. What number times itself 3 times gives us 8? What number times itself 3 times gives us 8? All right, Dayami, what number is that? 2. Hands if you agree with 2? Yeah. What is 2 times 2? 4 times 2? 8. All right, and now we just bring down the exponent of 4, and that gives us 2 times 2 times 2 times 2. So what is 2 times 2? 4. What is 2 times 2? 4. What is 4 times 4? 16. Woo-wee. All right, 1B, being that it's Tuesday again, I need somebody's help. Everyone, can we simplify square root of 2 anymore? No, but we can get rid of it. Is that correct? So what do I do, Martin, to get rid of it? We multiply, by square root 2, top and bottom. Square root 2, top and bottom. So that leaves us with 5 square root of 2 over 2 times 2 is square root of 4. Therefore, the numerator stays the same. What is the numerator? 5 square root of 2. And what is square root of 4? 2. And 1C. To get started with 1C, I'm going to write my perfect square numbers. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 25, 6 times 6, 36, 7 times 7, 49, ... So, which of those paired with another number multiplied give me 75? Tell your neighbor, what number times what number gives us 75? Go with Miguel. What times what gives us 75? All right, help him out, Gloria. What two numbers? All right. So, if I was to pick one of these, since this ends in 5, which of these numbers ends in 5? Yeah, 25. So 25 times what gives me 75? Times 3. That is correct. Therefore, what is square root of 25, everyone? 5. So we cross that out. What's inside of the radical? 3. So we end up with square root 3. Woof. We're in fuego. In fuego. I don't even feel the AC. All right, let's go to number 2. How do I rewrite this side? Tell your neighbor, how do we write the left side? Then we're going to have Michelle enlighten us. How do we rewrite the left side of that equation? How do we rewrite that left side? What does that half power become? Michelle. Square roots. That is correct. Square root of 5x plus 1 equals to 9. What would be my next step, Allison? Before she answers, tell your neighbor what would cancel this square root. What cancels the square root? All right, Allison. A squared. We do that to both sides. This cancels that. We're left with 5x plus 1 equals 81. Tell your neighbor the last 2 steps, and we're going to have Natalia enlighten us with the last 2 steps. Tell your neighbor what to do for the last 2. All right, Natalia Espino, what do I do to leave x by itself? Subtract 1, subtract 1. That leaves us with 5x equals 80. And what's our last step, Natalia? Divide by 5, divide by 5. X equals 16. Whew. Man, these are, my word is, these are too easy. Not too easy, they are tweezy. Jaime. Let's go. All right, let's go to the last one, number 3. Just for the sake of time, I'm going to go over those one more time. Here it goes. It's going to go pretty quick, so stay focused. Change f of x to y equals x plus 5 over 3. Next, we need to get rid of the 3 that's dividing, so that means we need to multiply both sides times 3. We're left with 3y equals x plus 5. How do we leave x by itself? We subtract 5 to each side, and then we end up with 3y minus 5 equals x. Is that the inverse? No! We exchange the variables. 3x minus 5 equals y, and then we just change the y to f of x. 3x minus 5 equals f inverse of x. Cake? Yeah? Piece of cake? Choco flan? No? Oh, yeah, let's go. Hook me up a piece. Choco flan. You guys know what that is? Yeah, some of you? All right. If you don't, you're missing out. Next, change f of x to y equals 1/3 x minus 4. leave x by itself by adding 4 to each side. Add 4, add 4. We end up with y plus 4 equals 1/3 x. To get rid of that fraction, we need to multiply times the reciprocal or the fraction flip, which is 3/1 to both sides. 3/1. So this becomes a 1, so we're left with x. Distribute the 3 here and there, so that's 3y plus 12. Are we done? No, exchange the variables. That makes it the inverse. 3x plus 12 equals y, and then function notations, f, bless you, inverse of x. Ooh-wee. Piece of cake. You're like, Mr. Q, give us a pop party on this already. Huh, Julian? Let's go. Julian for Presidente. So maybe tomorrow we'll have it. All right, send that in, please. Send me your warm-up, please. All right, copy the agenda. Warm-up number 26 is done. Bless you. Today we're moving on to systems of equations. Last night was only practice just to review your factoring to see how well you did with that. Tonight I'm only leaving you 5 systems to solve. Thank you, Mr. Q. You're welcome. 5's good, right? Gio. All right, let's go. All right, to access the home play for tonight, copy this code. EWUMQ. 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 Last night's home play looked like this. Go to Canvas. There's a new module that should come up on your Canvas titled Systems of Equations. In there, you're going to find an assignment titled 8 Quadratic Equations, which is this one, so turn that in. I'll give you some time. Go. Also, when you're done submitting that, get a Cornell note ready. You do need a Ferrier model. And I am going to take a question from the home play in a little bit. So first turn it in and we'll go from there. So out of those 8, which one would you like me to go over? Let's see, who wants me to go over number 1? Who wants me to go over number 8? The easiest one of them all. All right, I'll go over number 8. Here goes. Hold on, let me make some space here. All right, here we go. Number 8. So, what is our first step? Set it equal to 0. X squared minus 100 equals 0. Next. Notice that this one is not a trinomial, it's a binomial. Question, is there something that divides the first term that divides the second term? No. Therefore, what's the last thing to check to see if this is a difference of squares? So first of all, is it a subtraction? Yes, that's why it's called a difference. And how about squares? Let's see. Can I take the square root of the first one? Yes, that becomes x times x. Okay. Can I take the square root of the last one? Yes, that's positive 10 and negative 10. And all that equal to 0. That's why these are called difference of squares. All right, and the rest is history. X plus 10 equal to 0. X minus 10 equal to 0. Minus 10 minus 10. X equals negative 10. Plus 10 plus 10. X equals 10. Graph. Is that crooked? A little bit? A lot better? Okay. Here we go. Positive 10, negative 10. The constant is negative 100, which is way down here. Somewhere down there. Cake, or should I say Tweezy? Yes? All right. Okay, I'll do a daily special. What other one do you want me to go over? Last one. Number 4? All right, the second easiest one is go over number 4. Here we go. Of course, first step is to set it equal to 0. 2x squared plus 10x plus 12. Next, what do we check for? Can we divide this one by a number that divides this one that divides that one? What number is that? 2. That leaves us with x squared plus 5x plus 6 equal to 0. Where do you get that from, Mr. Q? Well, what is 2x squared divided by 2? X squared. What is 10x divided by 2? 5x. What is 12 divided by 2? 6. Next, inside of the parentheses, one number goes on top, everyone. The 6. One number goes underneath. The 5. So what two numbers multiply give me 6? That when you add them, give us 5. 2 and 3, Michael Jordan, let's go. So we take this and write x times x. We get the 2 and we get the 3. Don't forget to bring down the other 2 and all that equal to 0. And last but not least, each of those equal to 0. 2 equal to 0, x plus 2 equal to 0, and x plus 3 equal to 0. So this is not true. Canceled. Minus 2 minus 2. X equals negative 2. Minus 3, x equals negative 3. And our graph, of course, and I can do these on my sleep. Let's go. We got negative 2, negative 3. What is my y-intercept, people? Positive 12, yeah? Somewhere over here. And my graph? Something like that. Let's go. Let's go. Cake. Or should I say Squeezy. Squeezy. All right, we good? Yes, Mr. Q. All right. So, tonight's home play. Look at that beautiful scenario right there. Systems of equations. Let's go. All right, here we go. Get a Cornell note ready, please. You do need a fair model. It's going to go super fast. So stay with me, people. Our objective for today, I can solve systems of equations by elimination and substitution. I can solve systems of equations by elimination and substitution. Write that down. Get a fair model going, please. The big box. What concept are we on now? Systems of equations. So we need to clarify that. Here we go. In your fair model. What are systems of equations? What are systems of equations? Definition. The set of two or more equations that have the same variable. The set of two or more equations that have the same variables. The set of two or more equations that have the same variable. Systems of equations. The set of two or more equations that have the same variable. The set of two or more equations that have the same variable. The set of two or more equations that have the same variable. The set of two or more equations that have the same variable. The set of two or more equations that have the same variable. The set of two or more equations that have the same variable. Take over the definition for systems of equations. Some of you are like, I don't know, really? Wow, I repeated it 1,000 times. Examples, write these down. Y equals x squared plus 5x plus 6. X minus y equals negative 3. Y plus 3x equals 0. Y minus 6 equals negative 3x squared. Now, according to the definition for systems of equations, it says the set of two or more equations with the same variables. How many equations do you see here in the examples? 4. So that means I can pick 2 of them, look up, and make a system. Can I pick the other 2? Yes, there's 2 systems there. How about, could I do this? Look up. Could I pick 3 equations to make a system? Yes, because it says what? 2 or more equations. How about using my technology? Check this out. Could I stretch this out? What? And make a system with 4 equations. Yeah, because it says what? 2 or more. Do they have the same variables? Yes, x and y. Okay, okay. Non-examples. Before you copy those, tell your neighbor why this is a non-example of systems of equations. Tell your neighbor, why is that not a system? Why is that not a system? Then we're going to go with Scarlett to enlighten us. Tell your neighbor why that one is not a system. Why isn't it a system? Why is that not a system, Scarlett? Different variables, that is correct. So question, guys, what is the first hashtag that you would add? What are systems? Pass someone, Scarlett. Julian, what would make a system? What is something important to remember about systems? Hashtag what? Say that again. Same variables, yes. Write that down, same variables. And what else? Hashtag 2 or more. And I'm just going to put EQs, or equations. That make sense? Yeah? Yes, Mr. Q. All right, good. All right. Sending your copious notes to the screen. I want to see your beautiful notes. Thank you for sending that in. All right, really quick, guys. From this point forward, it's going to go super fast. Turn this way really quick. Everybody go like this. Bear with me. See what I did there? Bear. Never mind. All right, so here we go. Writing utensils down, look up to the screen. So, systems of equations can be solved 3 different ways: by graphing, substitution, and elimination. This is a review. You guys seen this in 8th grade. You've seen it in Algebra 1. You've seen it in Algebra 2. And I trust that my colleagues, my other math teachers, did their work, and you guys learned all of this. Right? Now, I left you guys a video lesson on systems of equations by graphing and solving. You guys remember that? Yes. However, if you didn't see that, we actually did systems of equations by graphing on the warm-ups last week and the previous week. Is that correct? We would graph both equations, go to the intersecting point, and that would be the solution. Okay. Today, we're going to focus on substitution and elimination methods. We good? All right, the process, I'm going to start off with elimination method. Here's the process. Don't write this down. You have the code that you can go and look at the notes in case you get lost tonight. However, I am confident you won't. Here goes. To solve by elimination, we take these steps. Number 1, change the equation in standard form. Look up to the screen. What does standard form look like, Mr. Q? Look up. When both x and y are on the same side of the equation. This is called what? Standard form. When both what? X and y are on the same side of the equation. That's called standard form. That is called what? Standard form when x and y are on the same side. Miguel. We good? Next, we're going to eliminate one of the variables by adding, or in other words, by combining both equations. From there, we solve the equation that remains for that variable, substitute that into one of the equations, and at the end, we write the coordinate as a solution. All right, let's get cracking. Copy this one, example number 1. Copy that. Write the whole thing, not the steps, just write the instructions. Solve the system by elimination method. Set y equals negative 2x minus 5 and y equals 2x plus 13. Now, according to the steps, the first step is to write both equations in what? Standard form. Tell your neighbor what that means again. What does standard form mean? What does standard form mean? Now, I repeated it 1,000 times. I even yelled it. Your neighbor should know. All right? What does standard form mean? Let's go with Carlos. What does standard form mean, Carlos? All variables to one side. So let's look at this bottom equation. Look up. I'm going to use blue. Which variable needs to go to what side? The x to the other side to leave the two variables by itself, right? So watch. Subtract 2x, subtract 2x. So my new equation is y minus 2x equals 13. So one of them is done. How about this one? Is this one already in standard form? No. What do we do to send the x to the other side? Add 2x, add 2x. So my new equation is y plus 2x equals, what stays on the other side? Negative 5. Now, by now, your brain is starting to turn those gears inside. You're like, I think I remember, Mr. Q. Here goes the next step. Look up. Draw a straight line. And put a plus sign here. And we're going to combine both equations. Y'all ready? Here goes. What is y plus y? Y plus y. 2y. Okay. What is 2x minus 2x? What is 2x minus 2x? They cancel. That's why it's called what? Elimination method. Bah. Equals. What is 13 minus 5? 8. Now look at this little itty-bitty equation. Can you solve that? Yes, by divide by 2, y equals 4. So now we know what y is. What is it that we need to solve for now? For x. So question, pick either the blue one or the red one. Does it matter? No. Which one do you want me to use? Sarah, which one do we use, the blue or the red? All right, Sarah says blue, so let's go with blue. I'm going to rewrite it over here. Y minus 2x equals 13. But instead of y, what do we write there, guys? 4. Bring down the negative 2x equals 13. And let's solve. Minus 4 minus 4. Negative 2x equals 9. Divide by negative 2, divide by negative 2. X equals negative 4.5. Are we done? No. The last thing, you need to write it as a coordinate. What is x? negative 4.5. And what is y? 4. This is my solution. And what does that mean? If I was to graph both equations, that's where both equations, what, everyone? Intersect. Is that correct? Woo-wee. Yes. All right. Send that in, please. I want to see your notes. So let's see. Make sure we got the process down. First step, we change each equation into standard form, which Carlos said all variables to one side of the equation. That's what we did. Next, we combine the equations so that we can eliminate one of them, solve for the remainder of that variable, substitute that variable into one of the two equations, solve for the other variable, and write our solution. From 1 to 5, I'll comfortable are you with this? 5 4s, and a 6 over here. All right. Copy this one. Example number 2. Y equals negative 4x plus 10, and y equals 4x plus 2. I'm going to give you a head start for that one. You should be able to do that one by yourself completely. Very similar to the one we just did. Copy and go. All right, for the sake of time, here it goes. I'm going to start with the second one. Is the second one in standard form? No, I'm going to subtract 4x from each side. I end up with y minus 4x equals 2 for the second equation. Hands if you got that. Okay, good. First equation. What do I do to get the x to the other side? I add 4x to each side. Add 4x. So we're left with y plus 4x equals 10. So far, so good. From there, what do? We combine them. Draw a line across, put a big plus sign. Y plus y is 2y. 4x minus 4x cancels or eliminates. 10 plus 2 is 12. Last but not least, we solve for that variable. Divide by 2, divide by 2. Y equals 6. Am I done? No, I need to pick one of the two equations. Sarah picked the blue one. This time I'm going to use the red one to prove a point that it doesn't matter which one. Y plus 4x equals 10. Instead of y, I'm going to substitute 6 plus 4x equals 10. Subtract 6, subtract 6. 4x equals 4. Divide by 4. X equals 1. Am I done? No. What's my solution? What is x? 1. What is y? 6, and that's my solution. Hands if you got that by yourself. Some of you, yes. From 1 to 5, how comfortable are you with this? Yeah, we're getting there. Yeah. All right. Let's move on. I'm not going to have you send that in just for the sake of time. Go to the next one. Copy this one. Focus, focus, focus. You got x equals negative 2y plus 11 and negative x plus 4y equals 1. All right. Here we go. Let me zoom in. First step. Tell your neighbor, what is the first step? We check that what? They are in standard form. So look at them. Is the bottom one in standard form? What? Is the bottom one in standard form? Yes. How about the top one? No. So what do we need to do, everyone? Send the y over. How do I do that? Plus 2y plus 2y. So we end up with x plus 2y equals 11. And at that point, I draw a line, I put a plus, and I'm going to focus on this one. Look up. This is going to be my blue one, and the other one's my red one. So what do? Combine. What is x minus x? They eliminate. All right. What is 4 plus 2? 6y. What is 11 plus 1? 12. Let's solve for y. Divide by 6. y equals 2. Which equation do we want to use, the blue or the red? Gio, pick. Blue. All right, so I'm going to use this one. Negative x plus 4y equals 1. Negative x plus 4. If you have a number next to the variable, remember, open the parentheses for the variable to indicate multiplication. And what is y? Y is 2. So, here we go. Negative x plus 8 equals 1. How do we cancel the 8? Minus 8 minus 8. Negative x equals negative 7. How do we cancel that negative, everyone? Divide by negative 1, or multiply times negative 1. X equals 7. Solution. My solution is 7, 2. Solution. From 1 to 5, I'll come to you with that so far. Okay, we're getting there. And I know it's going pretty fast, but like I said, this is review. Good review, yes? Don't send that in yet. Let's go with, that one's too easy, but it's already in standard form. Let's go with, let's see. Go with this one, copy this one. 3x plus 3y equals 15. And negative 2x plus 3y equals negative 5. Are they in standard form, everyone? Yes. So question, look up to the screen. Julian is going to guide us through this one since he's already ahead of the ball game. Here it goes. If I combine these two since they're already in standard form, what do I get for x, Julian? 1x. What do I get for y? 6y. And what do I combine over here? It becomes 10. Wait a minute, Mr. Q, but I still haven't solved for a variable. Yeah, that doesn't work. Now, why did it work with the other ones? Let's see. Look up to the screen. Let's see if you remember. Why did it work with the other ones? Focus, please. What allowed me to cancel these? That they are what? Opposites. Okay. Do we have opposites on this one? No. However, what would be an opposite that you can think of from there to cancel? What would be the easiest one to eliminate, the x or the y? The y, but one of them has to be what? Negative. Which one do you want it to be negative, the top or the bottom? All right, so to make it negative, we multiply times negative 1. You're like, oh, snap. Oh, snap is right. Distribute, distribute, distribute. That gives us positive 2x, negative 3y, and positive 5. We no longer use this one. We use the top and the bottom. So, with that said, combine. What is 3x plus 2x? 5x. The y's eliminate. What is 15 plus 5? That's 20. Let's solve. Divide by 5. X equals 4. Am I done? No. Which one do you want to use, the red or the top one? The top? All right. So let's do 3 parentheses for x plus 3y equals 15. And instead of x, we're going to substitute a 4. That's 12 plus 3y equals 15. So minus 12 minus 12. 3y equals 3. And last but not least, divide. Y equals 1. Solution. My solution is 4, 1. All right, before we go, last one. Here we go. Solving using substitution. Look at this one. To solve for substitution, the first step, one of them has to be solved for one variable. Look at the two equations. Which one is easier to solve for one variable, the top or the bottom? The top. So if I leave which variable by itself would be easy, the y. Is that correct? Subtract 3x. Subtract 3x. We're left with y equals negative 3x minus 2. We no longer need this one. And now, look up. On the second equation, instead of having y, what do I write? All of that. So watch. I write 2 parentheses minus 3x equals 14. And inside of the parentheses, I'm going to write my y value. What is my y value? Negative 3x minus 2. Distribute, solve, substitute, and solve. Let's see how you do with that home plate. See you guys tomorrow. Bye. Bye, guys. Have a good one.